You ever see one of those massive container ships and just wonder, what is holding that thing together? Well, today, we're going to pull back the steel plates and explore the incredible, unseen skeleton that gives these giants all their strength. It is an absolute masterclass in engineering, built to take on the most powerful forces on the planet.
I mean, really think about that for a second. You've got a structure the size of a skyscraper, just floating there, getting slammed by waves the size of buildings. How does it not just bend, twist, and snap in two under all that insane pressure?
The answer, well, it's right here in this cross-section. It's not just one thing, but this incredibly complex, integrated system of bones and skin. Just look at all those layers and supports. Every single piece has a critical job. It's a total engineering marvel, designed from the bottom up, and today we're going to build one piece by piece. Okay, so every great structure needs a rock-solid foundation. For a ship, that foundation starts with its backbone, deep, deep below the water. The very first piece of a ship that gets put into place is the keel, and you can think of it exactly like a human spine. It runs the entire length of the vessel, and it provides that fundamental front-to-back strength that absolutely everything else is going to be built on. But you know, the keel is just the centerpiece. The real genius of modern ship design is the double bottom. This isn't just one layer of steel between the ocean and the cargo. It's two. And this picture shows you exactly why that's so important. On the left, you've got a single hull. If that gets breached, the cargo spills right into the ocean. Game over. But look at the double hull on the right. It creates this crucial void space. So if the outer hull gets punctured, the inner hull stays intact. It protects the cargo, and it protects the environment. Plus, that space is super useful for storing ballast water or fuel.
So the big takeaway here is that this isn't just about making the ship stronger. It's one of the single most important environmental safety features in modern shipping. It's literally a buffer zone between what's in the ship and the ocean itself.
And this wasn't just some good idea someone came up with. Nope, this was a lesson learned the absolute hard way. The catastrophic Exxon Valdez oil spill back in 1989, that event directly led to new regulations that made double hulls mandatory for oil tankers. It changed the entire industry forever. Okay, so our foundation is laid. Let's move up a level and see how the main body of the ship, its hull, is actually built. This is really the skin and the ribs of our giant. Now, the outer surface, or the skin, is called shell plating. Its most obvious job, of course, is to be watertight, but it's also a key structural piece. It works together with the keel to resist bending, and it handles these massive shearing forces. Those are the vertical forces from waves that are basically trying to slice the ship apart. But just like our own skin, the shell plating can't hold its shape by itself. It needs an internal skeleton to give it rigidity. And on a ship, we call this the framing. It works exactly like a ribcage. This slide shows the two main ways to do it perfectly. Look at the diagram on the left. That's transverse framing. See how the ribs run side to side? That's great for fighting off external water pressure. Now look to the right. That's longitudinal framing. Here, the main supports run the length of the ship parallel to the keel. It's a totally different approach, and the choice between them is critical. So which one do you use? Well, for any ship over 120 meters long, longitudinal framing is the standard. And why is that? Because, for a long ship, the biggest danger is something called hogging. That's where a wave lifts to the middle up and the ends sag down, and sagging, which is the opposite. Longitudinal framing basically turns the entire hull into one massive, super strong I-beam, which is way, way better at resisting those giant bending forces. So we've got a foundation and we've got a hull. Now we need to divide up the inside. But on a ship, internal walls aren't just for separating rooms. They are one of the most critical safety features on the entire vessel. They are literal lifesavers. These walls are called bulkheads. They are heavy-duty vertical partitions that slice the ship into a series of smaller, independent, totally watertight compartments. This diagram shows you exactly how a bulkhead fits inside the hull. And notice, it's not just some simple wall. It's a solid steel barrier that runs from the very bottom of the ship all the way up to the main deck, completely sealing one section off from the next. Their number one job is damage control. If the hull gets breached, a bulkhead contains the flooding to just one compartment, which can prevent the entire ship from sinking. They also act as firewalls, they add to the ship's overall strength, and they separate different kinds of cargo. And get this, There's even a special reinforced one right at the front called the collision bulkhead, and it's designed to be the last line of defense in a head-on impact. And really, the importance of this idea just cannot be overstated. Horrible disasters on passenger ferries, like the Herald of Free Enterprise, where a bow door was left open, and the Estonia, which had a bow door failure in a storm, they showed the world exactly what happens when watertight integrity fails. Hundreds of people died in just minutes because water could just flow, completely unchecked, right through the ship. All right, let's move to the top and finish our build. Sitting on top of this incredibly strong foundation and all these compartmentalized sections are the upper levels that we're all a bit more familiar with. And finally, we top it all off. The decks are the floors, but they also do a ton of work tying the whole structure together, adding strength. Hatches are those huge, reinforced doors that give you access to the cargo holds. And the superstructure? That's basically all the buildings you see on top, including the forecastle at the front and, yep, the poop deck at the back. So the most important thing to remember is that no single piece does the job alone. The keel, the double bottom, the shell plating, the framing, the bulkheads, and the decks, they're all locked together. They form one single cohesive structure that's designed to flex, to endure, and above all else, to survive. You know, we've spent a century getting really, really good at building these skeletons out of steel. But as we start looking toward a future of unmanned, autonomous ships and vessels powered by hydrogen or ammonia instead of oil, you just have to wonder, is this fundamental design going to change? What will a ship's skeleton look like in another 100 years?